So today we're going to cover section 5, which is on angles. So an angle is formed by two rays that have the same endpoint. The rays are called the sides of the angle. The common endpoint is called the vertex of the angle. There are three ways to name an angle. You can name it by its vertex, you could name it by the 3 points, or if your angle is labeled with a number. So let's say I put a little 1 in here. I could say that this is angle 1, this little slanty L looking thing. Instead of having to write out the word angle, I can put the thing that looks like an angle and then put whatever name I'm giving it. So you can name it with the vertex, so I could call it angle N. If there's a number inside here, I could call it angle 1. Or you can also name it with 3 letters, and the middle letter must always be the vertex. So you can name it and go from M to the N and then around to the O, or you can go in reverse, O, N, M. Now, when we're taking these tests and quizzes on Canvas, and again, if you can't put in, like yesterday on the quiz, it was hard to label a line and put the picture of the line on top, you can just type the word line and then put the capital letters. Okay, so same thing for an angle. If it doesn't give you the option in the equation editor, just write out the word in front. So in this angle that's pictured here, the sides are these two rays, NM and then NO. Where the two rays meet is called the vertex. Next one, again, still naming an angle. Now this time, before we just had a single angle. But if this vertex is shared, notice I could put a little 1 here, and then I could be referring to this angle right here, the ABD, and then if I put a little 2 here, notice there's a second angle in this picture, and I can call it DBC, or go back around also. We also have a third angle here, and it could be the whole thing. So if it asks you to name some angles in this picture, the first one, the blue one, I can call this, since I put a little 1 in there, I could call it angle 1. I could call it angle ABD. Remember, the vertex needs to be in the middle. I could also go in reverse and say it's angle DBA. And then for the red one, I can call this angle 2. I can also call it angle DBC, or go backwards and call it CBD. And then I can refer to the green one. The green one would be angle ABC or angle CBA. In this particular picture, you cannot just call any of the angles angle B. So you can't just say angle B, because we actually have 3 different angle B's here. But notice in all of my names, the letter B was the middle letter. Okay, so the vertex, where the two rays meet, is always the middle letter. But I can't just say angle B here, because I don't know if I say angle B, I don't know if I'm talking about this one, or this one, or this whole green one. So that's why I have to name it with 3 letters when you have more than one angle in the picture. Next slide is talking about interior and exterior part of an angle. So the region that contains all the points between the sides of the angle is called the interior, and the region that contains all of the points outside of the angle is the exterior. So everything that's inside here, inside the two rays, or inside the angle, this is the interior part, and then everything that would be outside of that is called the exterior part. Next is called the protractor postulate. Now, remember we had the ruler postulate, so this is similar, but now instead of using a ruler, they're talking about a protractor. And here it says, consider line OB and point A on one of the sides of OB. The rays they form OA can be matched 1 to 1 with real numbers 0 to 180. So here, if it asks you to find the measure of angle AOB, which could be written as the measure of angle AOB, remember this little M represents the word measure, and it's equal to the absolute value of the distance between the real numbers matched with ray OA and ray OB. So it's similar to the ruler postulate. Now, if when you go to measure an angle, so like it, notice there's two sets of numbers. I've got an inside row here, and then I've got this outside. So if I look at my angle here, and notice it's pointing here, I want to start at 0. So if I start counting 10, 20, 30, 40, I could use the inside numbers to figure out how big this angle is, and notice it stops at 140, so I could say the measure of this angle is 140. You really won't be using rulers or protractors, but just realize that this protractor postulate exists and understand how to read a protractor. If I wanted to, let's say I wanted to draw another angle here, and measure the side, this time I would use the outside numbers, because again, you want to start at 0 and count up. So this side of the angle, and if we put another point here, let's say this is D, I could say that the measure of angle DOA would be 40.
Miss Corey?
Yes.
So the small green one, how much is that?
The green one is 140.
Even the small one?
Small one.
Like,
Oh, inside the protractor here, this?
yeah.
Okay, so if you've ever seen a protractor, it's usually this clear plastic thing, and this is just like an empty hole. This right here. Maybe, I can go get, let me see if I have one. Actually, if there's time at the end, I'll go see if I have a protractor in my closet. You're only measuring angles when you use a protractor, this line down here. You don't worry about this part of it. It's a hole if you look at a protractor. Does that make sense?
Yeah, I've seen one before. I was just confused.
Okay, so we're only measuring from this line to here. So we would see where this points. And it's right here. So it goes from 0 to 140. Let's try the next slide. So when you measure angles, the tool that you would use would be a protractor. Again, we will not be measuring angles with a protractor. You'll be given either an expression for the angle measure or actually what it measures. Angles are always measured in degrees, and we have different classification for angles. There's 4 different names here. We have an acute angle, which is an angle between 0 and 90 degrees. Whenever I see the word acute, I think of it's a cute little angle. So sort of take the word acute and say that it's a cute little tiny angle. It's the smallest angle there is. Then a right angle equals exactly 90 degrees. If you ever see a picture of a right angle, it's going to be a square. So they would put a little square indicating that you have a right angle here. Obtuse angles are angles that are in between 90 and 180. So it could be an angle that measures 91 all the way up to 179. And then for a straight angle, that's a straight line. And it equals 180. So first, let's go ahead and I'm going to highlight the first one. So I'm going to highlight GHK. So G to H to K is this angle right here. So again, I'm going to start here at the 0, and it's going to count. So I'm going to use the outside numbers, and then I'm going to see where the ray ends up, and it's going to end up here around 125. So this is a 125-degree angle. It's an angle that's between 90 and 180, so it's obtuse. Then I'm going to do JHL. So J to H to L, and you can see that that's pointing at the 90. So this is a 90-degree angle, and it's a right angle. Now LHK is here. Let me do highlight. Notice that it's not starting at 0, so this is where we're going to need to subtract to figure out how big this is. Now, you could either subtract the inside or the outside. I'm going to do these inside numbers here. So I'm going to do 90 minus 55, because it's here and 55's here, so it gives me 35 degrees, making this an acute angle. So we could also do the outside numbers. So we could also have done 125 minus 90 and still gotten 35. So you can choose. Just for when we had congruent segments, now we're going to have congruent angles, and those are going to be angles with equal measure. So here, notice these little congruency marks. This indicates that angle A is congruent to angle D, or if you put an equal sign, you could say the measure of angle A equals the measure of angle D. That's what the little M represents, the measure. And then again, the equal sign with the wave on top, that's your congruent symbol. Pretty good. Next is another postulate. Again, the number isn't important to us. The name is. So just like before we had the segment addition postulate, now we're going to have the angle addition postulate. If you want to abbreviate this as AAP, you can do that. So here it says if point B is in the interior of AOC, then what we can do is add this piece, AOB, plus this angle, BOC, and that would give us the measurement of the whole big angle, AOC. So what we could do here is, let's say I told you this was 20, and then this one was 30, then I know the measurement of the whole green one is going to be 50, because I would do 20 plus 30, and then that equals 50. So you take two angles, add them together to give you the larger one. Here, if it says that if angle JKL is a straight angle, and point M is any point not on JK, then if I were to add JKM plus MKL, it's going to equal 180 degrees. Okay, so let's say I have a straight angle. And let me divide it. Let's put some points on here. Let's say A, B, C, and then D. So if I tell you that angle ABC equals 180, if it's a straight angle, then I know when I take ABD, let's say it's 110, then if I wanted to find BD, I could just subtract that from 180, and I can see that it's going to be 70 degrees. So what they're saying is ABD, the measure of that, plus the measure of, we'll do it in green, angle DBC, and it's going to be equal 180 degrees, because this little piece plus this little piece together are sitting on a straight angle, and it equals 180. So if I show you 110 plus 70, it equals 180. So what they may end up saying is ABC is a straight angle, and then they might give you, say, this, and they'll say, find the green one. And then you'll know you'll need to subtract from 180. Next one is an angle bisector. We saw a segment bisector. Now we're going to bisect angles. So an angle bisector of an angle is a ray that divides the angle into two congruent adjacent angles. So the original angle is this ABC, and then if they tell you that BD is the angle bisector, then that tells you that it creates two congruent angles. So as soon as you've been told that that angle has been bisected, know it splits it in two, and they're going to be the same measure. Now, you can either tell that something's been bisected by they might have the congruency marks, or they might actually also tell you how big each angle is. As soon as you see that you have the same number or the same marking, then you know that the big blue angle, ABC, was bisected. So when you have a bisector, it makes two equal angles. So ABD, this one, ends up being equal to this one because they told us this big angle was bisected. Next slide talks about congruency marks. I know we've already seen them, but congruency marks on segments look like these little tick marks or little dashes. Congruency marks on angles are going to look like little arcs. Now, if you have more than, two angles in your picture that you want to show congruency, Like for example, if I have two lines that cross like this, I could say this one and this one are congruent, but then to show that these match, instead of putting a single line, I would put a double line. This marking is also an indicator that something's a right angle. If you have a picture and they say, classify this angle, just a picture like this would not be enough information because we don't know if this is exactly 90 or if it's 89 or 91. The only way that we could classify this is to have some kind of number on here, or if they put the little square. And then if that little square is there, then I could say this is a right angle because I can see the little box. All right, next we're going to practice naming angles, and then we'll use our angle addition. Let's try this one now. So we're going to give other names for each of these angles. So the first one we're going to talk about is DEB. So D is here. Oops, let me go highlight. D to E to B. So you go in that order. D to E to B. So they're referring to this angle right here. So I can name this. It's got a number there. I can call it angle 4. I can also reverse the order of my letters and call this BED. I could also, let's see, what else can I do here? I could also, if I wanted to come all the way down to here, I could also call this CEB, or reverse of that, BEC. E needs to be the middle letter. Next, we're going to do CBE. So C is here, B is here, and E is up here. So we're going to go in that order, C to B to E this time. And notice I've got an 8 here, so I can say it's angle 8. And the other way to name this is just to reverse and put the E first, then the B, then the C. Because I can also go in this direction, as long as B was in the middle. Next is BEA. So this time I'm going to start at B, and then I'm going to go to E, and then to A. So B to E to A, and that's angle 3. The other way I can name it is to reverse the letters, AEB. E has to be in the middle for this one. Let's try number 4. This time DAB. D is here, A is here, and B is here. So D to A to B. I can call this angle 1. I can reverse the letters, call it BAD. And notice on this one, if I were to have kept going, another name for this could be angle DAC or CAD. Next one, number 7, or angle 7. Angle 7's over here. Oops. So angle 7, this one looks, let's go in this order. So again, the C needs to be the middle letter on this one. So for number 5, I'll write them down here. So I could call this angle EC. BCB. So I could go here to here to here. I could reverse that and put BCE. I can also have kept going. I could call it angle AE or ACE. I could also call it ECA. Now I could also go here, and instead of going all the way to the E, I could start with the D. This one's got lots of names. So I could go from the D to the C to the B, or in reverse, or I could have taken it all the way to the A. So lots of names here. So I could go.
For this one, I know we're taking notes, but do we write all those down?
You don't have to. Just be aware that you could do all of them.
Okay.
Okay. All right, number 9, or angle 9, sorry. I've run out of colors here. Let's see. Will gray show up? Let's see. All right, so for angle 9, it's right here. So I could call this E, and it's on, I've written on top of it EBA or ABE. This one only has 2. ABE. ABE or EBA. Let me see if I can erase some of this stuff. All right, so angles 1 and 2 together. Angle 1 plus angle 2 makes this big angle. So you would say that this is angle EAC, or you could also say it's EAB, or in reverse of either of those. Angle 3 and 4 are up here, so that's making this big angle, AEC. You could also do AED. You could also do DEA, do it in reverse, or you could also reverse the original one, CEA. Then 5 and 6 together, over here, it's forming this straight line, or the straight angle. So EDC or CDE. These are straight angles. They're also supplementary angles, and they add up to be 180. The only thing you can ever assume in this class is when you have a straight line. You can assume it's a straight angle. That's the only thing without numbers or markings that you can assume. Let's quickly try the last example.
I have a question on this page.
Yes.
So, why can't you add, like, when you do the angle M5 and then angle M6, why can't you just add the 6 and 5 and the M on the outside?
And put 2 numbers?
No, I mean, like, why is it number 9 angle M11?
Oh, you can't do that. Because these aren't angle measures, they're just names for it.
Oh, okay.
Okay? All right. Next. So we're given that this whole, let's see, LKN, so this whole thing equals 145 degrees. It wants us to find the measure of LKM, which is here, and MKN, which is here. So here comes my algebra again. So I know that the measure, let me do this in a darker color, let's see, I'm doing this one in blue. So the measure of angle LKN, the whole thing, is going to be equal to the little red one. So the measure of angle LKM plus the green one, which is the measure of L, M, K, N. So I'm going to do 145 equals 2x plus 10 plus 4x minus 3. I need to solve this algebraically. I'm going to combine my like terms. So this gives me 6x. I'm going to combine my numbers. 10 minus 3 is 7. And then drop down the 145. Move the 7. 138 equals 6x. Divide both sides by 6. And x equals 23. I'm doing 138 divide by 6. 2, 12, 1, 8, and 3. Okay, now it didn't ask for x, it asked for the measure of these two angles. So now I take 23 and I'm going to plug it in here. 2x plus 10. So 2 times 23 plus 10, 46 plus 10, 56 degrees. So the measure of LKM is 56. Now to find the next one, I could just do 145 minus 56, but let me go ahead and plug it in. I'm taking 4x minus 3, putting 23 in here, and then multiplying, I get 92 minus 3, and it's 89 degrees. So this one is 89. You could confirm that it is correct by adding, going back, and just double checking and adding 89 plus 56. If this does not equal 145, you've done something wrong. So that is it for section 1.5.